Today, I'm very excited to be joined by Belle Reid. Sarah is a performer and composer who plays trumpet, modular synth, and many other electronic instruments. When I first discovered her music a few years ago, I was blown away by how well the sounds from her trumpet were integrated with electronic sounds. Rather than feeling like a hierarchy or a duet between separate worlds, her music blurs the lines between the amplified trumpet and synthesizer in a way that really brings the electronic sounds to life. Sarah recently released a great album, Mass, that I've really been enjoying, which you can find on her website. She teaches music tech, physical computing, and electronic instrument design at Chapman University and Temple University. So with that all being said, I'm going to hand it over to Sarah. Thanks for joining us, Sarah.
Hi, thank you for having me. And thanks everyone for being here. My sort of loose plan for today was to share some of the development of my work over the last 5 to 10 years, I guess, specifically as it pertains to combining trumpet with electronics in various different ways. And I guess I should say more broadly, acoustic instruments with electronics. It's taken many different forms over the years, but there are definitely a few key projects that have kind of been a through line and a catalyst for a lot of my creative exploration. So I'm going to focus on a couple of those to at least start us off, and then we can sort of see how things develop. But before I get too deep into things, what I wanted to do was maybe share 3 ideas that are not really my own, but they're ones that I've been finding really inspiring lately that I think will help frame for all of you sort of where I'm coming from with all of this work and how I've been thinking recently about music, sound, and instrument design and instrument interaction in general. And then I'm also going to share a little bit of my own sound so that you can kind of get an idea of what the heck I do and what it sounds like. These are on such huge topics. You know, I tend to call myself an experimental musician. Say I make experimental music. That can mean so many different things to so many people, and it's such a broad term. But this little section from Experimental Music Since 1970 by Jenny Gottschalk, I find really interesting, especially this top sentence. The passage goes, "This is music that is about the time and place in which it occurs. It is transparent to it, responsive to it, and frames it in a way that makes the familiar seem very special. When experimental music is effectively made and presented, it speaks to our interaction with the world. It goes from the center, what we already know, to the margin, what we don't know, and back again, so that new realities are present along with, or sometimes even in place of, our previous perceptions of our own lives. This work does not suggest other worlds, but instead strengthens relationships with this world." I think that's really nice. I don't know. I've been reading that over and over again a lot lately, and I think there's something really lovely about it. Whenever I'm asked to sum up why I make music in a few words or less, I tend to use the words discover and explore a lot. And it really, to me, feels like I'm constantly trying to discover new sounds, even rediscover old sounds. And, I'll pick up my trumpet, which I've been playing for decades, and try to learn something new from it in that moment and in that day. The next one that I wanted to share with all of you is a David Tudor quote. This was pulled from an interview, and it's really short. It's just, "I try to find out what's there, not to make it do what I want, but to release what's there. The object should teach you what it wants to hear." So to me, this really speaks to a relationship with instruments where we are not just like in the driver's seat. We're not just like master of the instrument. You know, it's funny because I come from a musical background in which mastery over your instrument was the thing that we were really striving for, having complete control over everything. But once I started to work with electronic instruments and kind of broaden my practice to be more electroacoustic, more improvisatory, this idea of recognizing that the music is already there. It's in the object, it's in the instrument, it's in the moment, it's everywhere. It's just a matter of kind of being open to seeing what it wants you to hear in any, moment to moment, and to learn from it, I think is really lovely. So whenever I'm designing, patches or programming something or building an instrument, this is something that I'm really thinking about a lot.
That reminds me of actually our first masterclass with Mark Fell. We had a discussion about whether or not he considered himself a composer and whether or not he considered the patches instruments. And he was just that for him, the patches were the pieces themselves, because, there's no rules to how you use the patch, but just whatever it's capable of doing is the boundaries of the piece.
Yeah, that's one of my favorite topics, just where it all begins and ends, or if it ever begins and ends. Sometimes I think about MIGSI, this augmented trumpet that I've been working on for the better half of the last decade. And I'll talk a little bit about it, I think, in a few minutes, as a piece. Sometimes I think about it as an instrument. Sometimes I think about it as just the longest duration composition of my life so far, and the circuit board, the wiring, the schematics, the code, all of it's part of the composition, or all of it's part of the instrument and the compositions come from it. I think it's kind of, it's a really interesting idea. Yeah.
Right. And I wonder, it's interesting also to reframe traditional instruments with that mindset, like, is the clarinet and a piece? Yeah.
Yeah. I think that's really lovely. I mean, the maybe the clarinet as it is experienced by each unique performer is that person's piece. The last one that I wanted to share, I can't not share these ideas from Pauline Oliveros, who's been such a tremendous mentor and inspiration to me over my whole life. These are two separate ideas that are pulled from this book, Deep Listening, A Composer's Sound Practice, that Pauline Oliveros wrote. So they weren't actually presented in this exact order in the book, but they're both really strong and interesting. And the first one is, I differentiate to hear and to listen. To hear is the physical means that enables perception. To listen is to give attention to what is perceived, both acoustically and psychologically. So to listen is to give attention to what is perceived, both acoustically and psychologically. Attention is directed to the interplay of sounds and silences, or the sound-silence continuum. Sound is not limited to musical or speaking sounds, but is inclusive of all perceptible vibrations, sonic formations. The relationship of all perceptible sounds is important. I pulled this one out to share with all of you just because, I think there's a lot to learn there, and just considering the difference between hearing and listening. But there was a really big kind of transformation that happened in my personal development, my creative development, when I started to really explore sound for the sake of sound, not necessarily quote unquote musical sound or good sound, even just sound. And it was a really big turning point to all of a sudden realize that something that for whatever reason I had thought was bad, incorrect, bad technique, whatever it is, actually was really beautiful if you just kind of gave it a moment, or if you got past the physical discomfort that came along with it, or whatever it might be. If you linger there long enough to actually start to listen to all of these peculiar and odd and abrasive and uncomfortable sounds, there's often a lot of beauty in them. And a lot of my music hinges on being quite noisy and rambunctious and aggressive and all of these different adjectives. So I always think it's nice to kind of start off with that as a frame of mind.
Those were great framing quotes. That was
thanks. I try to never miss an opportunity to really share those ideas because I just think they're lovely. So I'm going to play this is a little excerpt from something. This was one of the last performances, bigger works that I did back in I think this might have even been late 2019 or early 2020. But regardless, what I'm doing with this is I'm playing, you'll see there's a lot going on, but I'm playing trumpet. There's a couple modular synthesizers there. I've got my laptop computer. There's a lot of, these light bulbs are turning on and off and kind of flashing, but everything's being controlled with my trumpet. So I thought this would kind of be an interesting place to start in the conversation of trumpet plus electronics. So I'll play this little clip. Sorry, it's all a little dark, but I guess that's one of the difficulties of trying to make a performance that involves light bulbs. Is that when you film it, it's quite high contrast.
Right. I have a question about that.
Yeah.
So I know that a lot of what you're about to tell us is how the control system works, but I'm wondering when you're performing the trumpet and also controlling, a list of 10 other things, do you have to think about the other things, or is it all kind of integrated into the types of things you would already be doing? And therefore, are you thinking about a million things at once, or are you just thinking about playing trumpet?
Yes. It's a terrible answer. Yeah, no, that's a really good question. So you're right. I will kind of share a little bit about the design of this instrument, which I think will answer a little bit of that, but it's a bit of yes and no. So in this particular piece, there's so much going on that what I ultimately was thinking about in the moment, I had set things up so that I was able to more or less kind of improvise the piece and just play and focus on playing the trumpet. Well, focus on playing my augmented trumpet, which is not the same as playing a trumpet, because I'm also thinking about other things, certain other things like hand tension on my left hand and the tilt of my instrument. And those were controlling different aspects of the sound. So, you're thinking about more than just playing the trumpet, but less than what you might be imagining. I wasn't thinking about like, oh, this light and this synth and that computer and that sound and my trumpet and the next note. And, it's really just kind of the trumpet plus a little bit of extra stuff. But really, I tend to refer to this instrument as a gestural interface. And the idea behind that is that it's extracting gestural information from me. So there aren't any additional, maybe I should actually, I've got a little image that might be helpful. Mm-hmm. This is a little picture of my trumpet. For those of you who are seeing this for the first time, I refer to this instrument as MIGSI, which you can see here at the top. It stands for Minimally Invasive Gesture Sensing Interface. The way that it works is that it has some sensors that are attached to the trumpet, and those sensors detect essentially motion, different types of motion. So the displacement of my valves up and down on the horn, and the tension of my left hand on the sides of the horn, and also the tilt of the instrument, kind of, and the movement of the instrument that way. And so there's no additional sliders or knobs or buttons, right? So I'm not splitting my brain that way, where I'm having to also think about playing the 3 valves on the trumpet, but also hitting buttons and things like that. I'm just holding the trumpet and playing, and that information is being sent over to my computer, which is then being used in a meaningful way. I suppose the exception to that is that you can think about these little pressure sensors as buttons. Mm-hmm. You could, and I sometimes use them in that way. So really the challenge is not so much on the trumpet end, it's on the computer end, figuring out how to map all of that data so that it does things that are musically interesting. Right. And that's where the last, 7 years of my life has been dedicated, is to the mapping, the data handling side of things.
Right. I now understand the minimally invasive part of that thing, though. It's all trumpet gestures that were already happening.
That's right. Yeah. I was really interested when I was designing this. I was coming from like I mentioned earlier, I was coming from a classical trumpet background, and maintaining the natural acoustic sound of the trumpet was super important to me. And at the same time, not damaging my horn was super important to me. A lot of the other ideas that I was seeing, and by the way, just put that up on the screen if anyone wants to take a picture of it or something. This work that I'm doing is not in isolation. It's building on a lot of other really amazing, really, really groundbreaking work from quite long ago, I might add. So, but a lot of these projects were very, in some way destructive, or not destructive, but, they required drilling a hole through the horn or permanently modifying the trumpet in some way. And I was really interested in doing something that could come on and off like a mute, put it on for one song or one piece of your set and take it off for the next. And so it was like a logistical thing, but then at the same time, there was also this idea about cognitive bandwidth. Like, how much can I handle? I'm just a trumpet player. How much can I handle in the moment? Do I really want to be playing the role of trumpet player and technician at the same time? What can I do to lessen that kind of burden? What can I do to just make it such that the gestures that are inherent to playing the trumpet, like pushing down valves and slight movements, breathing, all of that, can be leveraged to create meaningful extra stuff,
Right. That's so great. I mean, it reminds me of some demonstration videos I've seen of people whose live sets involve running 25 things at once. And it feels like you memorize a set of instructions rather than interact with it in a way that kind of allows spontaneity or any kind of musical thinking. This is such a perfect opposite of that rabbit hole that I think is easy to fall down.
Right. And it's funny because I just started off by showing you all a performance that had far too many things happening. I mean, it was ridiculous. It was a performance as part of my doctorate. And so I was intentionally just I had resources and I had a concert hall that I could hang light bulbs from the ceiling in. And I thought, why not? Let's just go for it and see how crazy this can be. I really wanted to just create this whole kind of ecosystem and environment that I could manipulate and control with my trumpet. So, and interact with, I think, is actually a better word than control. But yeah, you're right. So it's kind of funny. The elaborate setups are fun too.
Sure. Yeah. Well, I mean, are you not interested in doing that kind of setup anymore?
Oh no, I absolutely am. Totally. I also think it's lovely I'm a big, big, big fan of a setup that's small enough to throw in your backpack and be minimal. So yeah, I don't think there's necessarily one way or the other to go.
Cool. Well, we actually have a couple questions, if you don't mind.
Sure, yeah.
Somebody's asking if the acoustic trumpet sound overwhelms the electronic sound while you're performing, the morphed electronic sound, amplified and electronic sounds.
Yeah. So there's actually my practice in this regard has changed a lot over the last few years. At the very beginning, when I first designed this interface, I wanted, for various reasons, I had this goal that the acoustic trumpet would be acoustic. And that was it. I had no microphone in the horn. I wasn't processing the sound of the trumpet at all. And then the gestural sensor data would be used to synthesize entirely new sound, either by using max MSP or by converting that data to control voltage and working with a synthesizer. But it was really like a duo between electronics and trumpet. And then I slowly started to integrate audio processing as part of the kind of world of MIGSI, where I had a microphone that I would play into and I would capture the sound of the trumpet and, put effects on it and stuff like that. So balancing that has really just been moment to moment based on where you are. If you're in a particular type of concert hall, you'll just simply send more or less of your dry trumpet signal through into the mix, or more or less of the affected sound. So it's always about just tuning to the room that you're in, which is not a super exciting answer, but it's just the way it usually is. But there are also one other thing that I did start to explore was using these mutes. I don't have a picture of one, but they're made by Yamaha. They're called silent brass mutes, and they completely remove the sound of the trumpet. And there's a little pickup, like a little auxiliary cable, 1/8" pickup in them. And then you can run that into your computer. So you can have 100% electronic processed sound with no acoustic.
Oh, wow.
Yeah, which is strange.
Yeah. Does the sound coming out of the pickup sound like a trumpet, or is it more just usable as like a control signal?
You can use it in any way you want. They were designed as practice mutes to use in hotels and airports and various places like that. So you have the little pair of earbuds and you can hear yourself. You can put really bad sound or interesting sounding reverb on. But yeah, you can use it as in this case, what's most common is that people would use it as a control. Like you would turn it into, your trumpet could sound like anything that you wanted,
Cool.
except for a trumpet.
Use it to control a MIDI trumpet or something.
Yeah. If you wanted to.
For the silencing mute, is that something you don't use very often?
I don't. I have one. I got one of those mutes when they first came out with them. And I think since then they've gotten much better. But I don't use it very often. I've used it, like I said, only once or twice just for some experiments. It's fun, but
Yeah. Cool. Okay. A couple of other questions. Do you have any generalized recommendations for anyone who would be interested in technologically augmenting an acoustic instrument?
So if you're not familiar with NIME, I would start there. NIME is an acronym for New Interfaces for Musical Expression. Here, actually, let me show you. It's there at the top of the page, NIME. This is an example. This is one of the papers that I've published in the NIME proceedings. It's an annual conference, and they do a published proceedings, basically a huge collection of articles. And there's also some video presentations and other things. Last year, they did it all virtually. So it's just an incredible resource. And what's really nice about NIME is that everything is open and accessible. There's no paywall or anything to access this. So this is where I started, not this specifically, but NIME is where I started. I was interested in, augmenting my trumpet. I scarcely knew what that meant, but I was really optimistic about what it could mean. And I went into the NIME archive, which you can just Google, and you'll find it. And I searched for keyword trumpet. And I found, a whole bunch of stuff, these 5 people plus many others. And this project here was something that basically became the springboard of MIGSI. So what I ended up doing was I read this article. They had been doing a lot of really interesting research about optical sensors inside of valves. They kind of did this first step and then said, that's it, we're moving on to other ideas. And so I kind of took it and ran with it and developed it out a little bit further. So what I recommend is that you just take some time doing your research and digging through NIME, read the papers. You could look up, often there are related websites connected to either the people who write the papers or the artists who demo the work and so on. And that's going to lead you to a lot of places. Yeah. I think that's probably my top suggestion. Yeah. One other thing I guess I'll mention is that in terms of sensors, Adafruit and SparkFun are 2 companies that produce sensors and microcontrollers and all of the hardware stuff that you might need for a DIY kind of project like this. And they build them with breakout boards, which basically means you don't need to have, fancy machinery and to do surface mount soldering. You can do it all by hand because they have these breakout boards. So it's a really good place to start for prototyping. And in fact, the prototype of MIGSI used those breakout board sensors from Adafruit, and in some ways still uses them. So they'll get you. Not only will they get you up and running, but they're great. You might not actually have to move on from them. So
you said that was Adafruit and SparkFun?
Yeah. They also have tons and tons of tutorials and resources on both of those websites, code snippets that you can start from. You're going to be well on your way if you look at those 3 resources.
Great. Well, thanks very much. Here's one more question. Amazing that you found good triggering from the acoustic trumpet sound. How much of your creative energy and ideas do you get as a reflex of example random effects from your sound generators? And have you tried to capture random ideas into more traditionally composed pieces?
Yeah. So I definitely do enjoy working with randomness and leaving certain aspects of the sound generation and or the sound processing a little more open-ended. That kind of comes back to the earlier idea about having this relationship with your instrument where you're simultaneously the performer and kind of like an observer, or a partner. So I very much am interested in that. One of the things that we kind of encountered early on that was a problem in regards to mapping was this like one-to-one mapping relationship issue, which I can explain a little bit more. So at the very beginning, what we were doing, and I'm just so that I am giving credit where credit is very deeply due. I say we, my co-collaborator, Ryan Gaston, and I have been working on MIGSI since its very beginning together. And Ryan is not here right now, but is very much on team MIGSI. So when I'm saying we, that's who I'm referring to. So from the beginning, when we were working with sensor data from the horn, we were doing things like every time the valve would go down, something would happen. A sample would be triggered, or the pitch of an oscillator would go down, or something like that. And it was really satisfying and exciting to see that like very close relationship. Mm-hmm. However, very quickly became predictable and a little bit boring for the listener, but mostly for me, because I was just like, gosh, now I don't feel like I can actually improvise and play this trumpet, this really great instrument, because I know that every time I push down that first valve, that thing is going to happen. So if I don't want that thing to happen, then now I have to avoid like, everything on the first valve, every possible valve combination that includes the first valve, which is just crazy. So I was making decisions I was feeling like stuck between a musical decision or musical impulse and a mapping based decision. I hope that makes sense. So we worked around this in a few different ways. This is a pretty big conversation, but I can see if I can give you the like rapid 5-cent tour. One of the things that we did that was really effective, and this is going to sound painfully simple, is that we actually just started to introduce a time delay between the user input and the output or the result of that input. I was really inspired by Don Buchla, was a electronic instrument designer who created one of the first voltage controlled modular synthesizers in the 1960s. And there's this really great article where he's being interviewed about one of his instruments. And he talks about how he thinks of an instrument as having 3 parts: an input structure, an output structure, and something to connect them in the middle. And it's so simple and obvious, but if you think about like a trumpet or a piano, all of those things are connected. They're all stuck together. In an electronic instrument, we get to remove them from one another. So that connection part, it doesn't have to be one-to-one. It doesn't have to be immediate. It can be anything in between. And so what we decided we could start to do was make certain gestures immediate and one-to-one, while other gestures could be one-to-many. You could do push one button and have it generate 15 things that all go in different directions. Or you could push one button and have it hang out in the void for 15 seconds and then circle back over on itself and surprise you. So that's the kind of way that we are integrating this randomness, is to displace input and output in time. Does that make sense?
Yeah, absolutely. Really inspiring. I mean, I'm running across similar problems in some current projects, and I haven't tried that yet. I love that idea. Mm-hmm. Would you mind giving some examples of what types of gestures would work with a short delay and what types of gestures would work with the long delay, or what types of gestures would be closer to one-to-one and what might be a little bit more abstracted?
Yes, I can try. I will say that it's important. I think it's important to still maintain some kind of one-to-one somewhere. We went full into the like, let's displace all of the data. And it felt like I had no control anymore at all. Like the trumpet was just going to do what it wanted to do. And that wasn't as satisfying. So one of the very first pieces that we made in this way was this piece called Pocket Fig. Weird name, but fun piece. And I can play a little example of it. This is where we were basically like, this is like an etude in this idea. So we have the valves. Every time I'd push down a valve, it would trigger the playback of a pre-recorded trumpet sound from a buffer at a different speed, like kind of a granular little snippet of playback. As the piece progressed, that the relationship between my valve presses and the playback would gradually start to lengthen. So at the very beginning, it was immediate. I'd push a valve and you'd hear bloop, 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 bloop. And then as it progressed, I would release the valves and you would hear nothing. But then anywhere from 1 to 6 seconds later, you would hear it. So it became like it, you know, we were kind of easing the performer into this not so tightly knit relationship. But all the while on the FSRs, the hand tension side here, I had an immediate one-to-one control where I knew that if I wanted to bring in this kind of more drone-y sound, I could. So I was able to change the texture very quickly, kind of on the turn of a dime. I can play a quick example of this.
Yeah, that'd be
if
great.
That would be useful. Okay. Ooh, it's a funny still frame. Okay. Here we go. So that drone, when I switched over to playing the air sounds, the kind of drone that you heard, I was activating with my left hand. So that's a moment of kind of demonstrating, like, I wanted to take the piece in a certain direction. And I knew that because I had that one-to-one relationship, I could kind of nudge that into happening. And it would be like a pretty significant structural change for the piece.
Right. Wow.
Does that answer your question, kind of?
Yeah, definitely.
Okay,
definitely.
good.
So you said that this electronic sounds were buffered recordings of Trumpet. Would the type of gesture that you were doing with the valves or other sensors sort of correlate to the samples that were chosen, or were the samples randomized?
I think at this point it was very random. We were really dealing with like one new variable at a time. So yeah, we just had this sample in there of me playing similar types of sounds. And then with each time, every time I would raise the valve. So this is another thing about mapping that I think is useful to maybe touch on. What we ended up doing is we ended up kind of zoning out sensors, continuous sensors, and also thinking about the direction of the sensor. So one thing could happen on essentially the key press or the valve down gesture, right? And another thing could happen on the valve up gesture. And moreover, we had this idea, but we didn't get it implemented until much later. There could be zones along the valve, right? So at the very beginning, I was half pressing the valve and nothing was happening until I pushed it all the way down and released it, right? Because I had set the threshold for activation on that sensor to be quite low. So you're taking a continuous sensor that gives you a range between, whatever it might be, 0 and 1,000, or, whatever it is. And you're scaling that to something that's usable, but then you're also dividing it up into zones so that you get multiple potential actions or multiple potential routings for each single sensor. So yes. So for this particular piece, they were all based on the release gesture. This is something I've given a lot of thought to, is if you want a sound to happen on the onset of a gesture or on the release of a gesture. And it might seem kind of arbitrary, but it really makes a difference. So it's just something that you kind of have to experiment with. But for me, I really like to be able to kind of like like let go and like go, huh, and then have the electronics just kind of fly out, on that release. So anyway, it's just a thing, kind of a thing to play around with. But yeah, they were random. It was randomly choosing a playback speed and also a grain window, like a duration from the buffer.
Cool. Yep. That's super helpful to understand and really inspiring. Great. So the questions are actually piling up. So if you don't mind,
okay,
more.
Yeah, I can try to give shorter answers too.
No.
I tend to kind of go deep into things, but
better to go deep, I think.
Okay.
But the audience disagrees. Let us know.
Yeah.
One quick question. Will Sarah share her slides with us? Can you share these slides?
Oh, I guess I could. I mean, this is kind of like a pile up of 5 years worth of collecting slides, but I could certainly maybe clean them up a little bit and share them. I'm fine with that.
Cool. Well, yeah, we've got some interest. Multiple people asking about that.
Oh, okay.
Okay, I'm just going to start reading through the most thumbs up questions. So from Matt Carr, what is your process like in creating max patches that interact with your trumpet? Do you have a clear idea of what you want to build beforehand, or do you explore and get surprised from the building process and have that direct the patch?
This is such a good question. Part of my plan for today actually was to show you all kind of the very messy progression of max patches over the years. A lot of them, regrettably, are so old and messy that they won't really work. I can't really open them up, but I have screenshots I can kind of show you. And regardless, it's not so much about what was specifically in the patch that's important, but kind of the iteration process that I think is actually a more significant takeaway. So often when I'm showing off and talking about MIGSI, I bring up this, which is the current GUI for the MIGSI application, which is all built in Max. And the GUI is the handiwork of Ryan Gaston, my collaborator. I cannot take credit for this beautiful GUI. And people often look at this and they're like, yeah, okay, cool. That's how the heck do you get there? Right? Good question. So I just wanted to I have some slides, some pictures of previous Max patches to sort of show you how things iterated and developed over the years. And now to answer the specific question, the process is largely, we have some kind of idea, like a kernel, but then we don't really know how to get there. So we put down one brick and then we're like, oh, cool. Okay. And then we put down another brick and we're like, oh, that was a little unexpected, but maybe actually worth exploring. And we just kind of go from there. So it starts with there's something that is making us want to do it, right? Either to explore a technical idea or to explore a sonic idea. Like in Pocket Fig, we were interested in exploring this idea of the granular kind of percolation sound idea. But the end result is very rarely actually like equal to what the original goal was. Mm-hmm. And I think I can say that with everything I do, and I'm fine with it. It's like whatever gets you going creatively is valuable and you should run with it. But whatever you end up with at the end is also valuable, even if the two things are not the same, In my case, they seldom are. So the very, very beginning of the MIGSI app was nothing but data handling. All that it did was it received data from MIGSI and allowed us to scale it. So this left side of the screen was the original MIGSI application. That's it. It didn't do any sound. It didn't do any synthesis. It didn't do any processing. It just received serial data and allowed us to scale the crazy numbers that were coming from the sensors down to be between 0 and 1. Mm. And then we have this switch stuff. This was never fully functional, but this was our early prototype of trying to figure out this zoning thing, like the threshold zones. And then this was the patch for Pocket Fig, the piece we were just listening to. I'm not going to talk too much about this particular patch, but just because it's so old, it's so foggy and scary to think about. But we were embedding this data receiver here at the top and then pulling out all of the values from the different sensors into the patch. So, not GUIfied or anything. And then, a couple months later, or a year later or so, I was asked to go on tour with an artist, and they wanted electronic trumpet, MIGSI trumpet, but they wanted effects. They wanted sound processing and delay and reverb and frequency shifting and all these things that I hadn't considered. And so we really quickly scrapped together this like half-baked thing where we have the same data handling. It got a little bit of a facelift in terms of how it looked, but it's the same code behind it, just slightly different colors and stuff. And we started to play around with these different audio effects.
So the data from the trumpet from MIGSI would control the effects parameters?
Yeah. So this was also the beginning of, this kind of, all of these little drop-down menus are buses. So they're like patch cables on a modular synth. So you're able to basically open up the drop-down menu and say, I want to use the data from, sensor number 1 to modulate the bandwidth of this bandpass filter, for example. So all of this eventually got cleaned up and developed into here, but it all started kind of just looking really scrappy and just whatever it was bare bones. It was whatever we needed for that show. Cool. Yeah. And the progression, really for years and years was like motivated by, we have this idea, we have this opportunity and we need to kind of scrap something together. Another thing was we got this wonderful opportunity to work with a couple of vintage Buchla synthesizers for a week. And we were like, okay, we got to try to hook up MIGSI and get MIGSI to play with the synths. Mm-hmm. And so again, that was kind of the starting point of trying to figure out how to convert serial data over into control voltage. And we were using something called an ES8. It's a mod for any of you out there who are just dying to know. It's a module made by Expert Sleepers. It's a Eurorack format audio interface, and you can use it to interface between external audio and a modular synth and convert that into control voltage. And this moment gave us the idea. Up until this point, we had just been building these patches. Like, here's a patch, here's half a patch, here's kind of functional patch. And we were like, wait a second, why don't we make something that is modular by design so that we're not building a whole new instrument every time we want to make music with MIGSI. Instead, we are, going to an instrument the same way you go to a modular synth, and you're just patching it together in a different way. And so we kind of went back through the last 5 years of ideas, and we just mined the ones that we liked. This one worked, we'll take that. That one kind of worked, we'll take half of it. This one was good. And we put them all together, plus a few other things, into this app. And so that's really what the final version of the MIGSI app is like a modular kind of environment for working with this data.
Wow. I'm just looking through it. So if you could just give kind of a big picture overview of like the main ideas that made it into the final version.
Yes, I'll give you a tour. Here we go. So external handling, external input handling, right? This is basically has an envelope follower, mic input. There's a filter. There's a problem with this. So I kind of don't really use it, but regardless, external input. There's a granular processor. So this started early on with the pocket fig explorations and kind of evolved and changed over the years. But this basically allows you to send your external signal in to a granularizer to chop it up into little pieces and play them back at different speeds and grain sizes and all of that.
And sorry, but the way that something like this would work is that you would connect MIGSI control parameters to, for example, granular parameters, right? It's not something that you would ever use the mouse to play with in a live performance.
Yeah. I mean, I sometimes, you're right. Yes. So in an ideal live performance, MIGSI data would be connected to these drop-down menus. Mm-hmm. Yeah. Now, that's not always the case. I mean, I went through a period of time where I was having some technical issues with the wireless connector on MIGSI, and so the data was really intermittent. Sometimes it would start and stop. I'm using this little XB radio, kind of XB receiver dongle thing. And so I had a whole bunch of concerts. I had like a line of tour dates set up, and MIGSI was acting up. And so we were like, okay, we need to figure out a way to implement MIDI control. because I need a backup.
Mhm.
So, but the cool thing about that is like the reason why I'm telling you all this is because some steps forward are fueled by a creative impulse and others are fueled by some kind of technical problem, right? Or necessity. And they're both great because what ended up happening, we implemented MIDI. And then I realized it was really fun to have a MIDI controller on the table next to me for certain utility functions that maybe weren't so performative. And so that I could have both. And so I could play with Migsy and have all of that gesture right here in this world. But then when I wanted to change something on a more, macro level, or I wanted to go to a new preset bank or something, I could use my MIDI controller. And so I never would have gotten there if we hadn't had this really stressful period of time where things weren't really working. So all that to say, embrace the chaos. If things aren't working, it's, it can be ultimately in the long run a really effective way to kind of level up stuff.
Right. Absolutely. Okay. Anyway, sorry for interrupting the tour.
That's okay. So these three things, these are the exact same, just a duplicate. These are all synthesis engines. I'm not going to try to explain these in depth because that could be another multi-hour conversation. But what I will let you know about is that if anyone's curious, there's another NIME paper. Oh boy, where is it? Here we go. That you can look up in the archive. It's called Perspectives on Time, Performance, Practice, Mapping, Strategies, and Composition with Migsy. And it talks a lot about not the trip, but the TCO, which is this one right here. They're essentially, in a nutshell, though, these are chaotic oscillators, basically chaotic synthesis engine tools. So we were really interested in that kind of chaos-driven sound world where you can like nudge it. Again, this all kind of goes back to what I was talking about at the beginning. You can give it just a tiny bit of information and it will come back and totally surprise you, and be like, oh yeah, I heard what you said. And here's 50 other ideas to react to. And then down here at the bottom, we have this instrument definition area, which is basically a preset handler. So it allows you to store 10 different states and recall them. So this was really useful. I could call up a set, for example, or a particular JSON file for a particular show. The bus access, this all comes in from Migsy. So these are like sensor 1, sensor 2. It's all arbitrary, but valve 1, valve 2. Another bus system for internal modulation sources. Like, for example, we have a fluctuating random voltage that you could pull up here and send somewhere. This is just like a kind of output handler, like a mixer. But this all came directly in from this one that I was showing you. This is kind of like a delay pitch shifter type thing. I know it's really hard to look at someone else's GUI and kind of understand the workflow, but it's even harder to look at the guts of the Max Patch and understand at a glance. This is a OSC input output window. And then this is all just like the raw data coming in from Migsy, scaling it and so on. There's a bunch of other little submenus. A lot of this is still in development, very much still in development. Some of it's half functional. Some of it is really in beta. Like we built this quad spatializer thing that I think I used for one concert, and then 2020 happened. And so we were just patiently waiting to be able to get back into a space where we can explore that a little more.
Nice.
Yeah.
Cool. It's really great to see the like you said, without fully understanding all the individual elements, it's nice to see what tools are making up these pieces and performances. We have one question specific to Pocket Fig. Asking how much of the trumpet part is improvised.
The live trumpet. Oh, it was all improvised. Well, okay. It was all improvised, but the structure of the piece was set. So it was kind of like we made a scaffolding for the piece. We knew, because if you remember, we were doing these things where as the piece progressed, the relationship between the input and the output, the gesture and the kind of data result was getting displaced over time. And so you'd push go on the patch, and then like 10 minutes later, all these things would start to behave differently. And then the piece would just kind of end. So we had this fixed structure for the piece, but everything in between was improvised. Yeah.
So follow-up question, has anyone else performed Pocket Fig, and what would you tell the trumpet player to do?
No, no one else has, and that's largely because there's currently only one like MIGSI hardware interface.
Mhm.
Yeah, it's definitely a goal of mine to be able to let that not be the case. But there's just still so much we're figuring out that we feel like we're still a ways away from being able to hand this to someone else and have it actually function. There's all these funny little things, and I'm sure those of you who program or honestly do anything with technology can understand. There's these funny little quirky things that we do that are little workarounds for different bugs, and didn't implement that properly, but I know when I open it up to do these 5 things to make it work. It's like how you have to, kick the TV and it starts working or something. Like you just have these funny things that only you know, but you couldn't hand it to someone else and have it work without a big headache. So that's kind of where we're at, unfortunately. But yeah, I think if I were to hand it to another trumpet player, though, a lot of the instruction would be to kind of, specifically with Pocket Fig, would be to kind of listen and respond to what you hear. Because the really interesting sonic interactions happen when the trumpet live and pre-recorded are kind of bouncing off of one another and like having in conversation. So it's kind of this like copycat feedback loop type improvisation where you're hearing something and you're like, oh, I can do that. And then meanwhile, something else happens, and like like 2 creatures chattering.
I love that.
Yeah.
Awesome. So, can we do one more question, or is there anything?
Sure.
Okay, great.
Yeah, no, it's fine.
So, while performing, how do you consider harmony? Do you think about what harmonic colors you're going to use as part of a composition process, or are you more open to changing on the fly?
I would say that in general, I am a little bit more preoccupied with texture and gesture than I am with harmony or melody. I'm listening to it, and I'm a little bit more interested in terms of compositional mindset of like coordinating gestures of events and working with timbre and texture. So usually when I'm composing, that's what I'm focusing on. I don't know if that really answers your question, but I also just remembered that there was a question from earlier about composing, and I kind of went on a little bit of a tangent and kind of forgot about it. So I apologize to the person who I half answered your question from earlier. And I don't even really recall what the second half was. Oh, I don't know.
Maybe do you mean the question about using randomness in composing?
That might have been it.
I think you answered that pretty well.
Okay. All right. Great.
We're trying our best.
Yeah, it's a lot to keep track of.
Mapping. Some people are following up on the question about mapping. So maybe, tell me if you think this is a good way to answer that question, but looking at the full MIGSI patch right now, maybe what's an example of a particular sensor that would be mapped to a particular part of the patch? I don't know if that's a good question, just an idea.
Something that I love to do, and unfortunately, just for everyone watching, this is a really CPU intensive application. We tried to open it and run Zoom at the same time, and regrettably it kept crashing. So that's why we're looking at a screen capture and not anything a little bit more exciting. But what I can do here, how about this? This might be interesting. I'm going to play like a few seconds of this video clip, which is just trumpet and MIGSI. You can see the app in the background, and then I can tell you a little bit about the mapping that's going on. Does that work?
That sounds perfect. Thank you.
Okay. All right. Here we go. I guess I can pause it there. There's a different section that I guess I could try to jump to that uses a different part of the app, but we can talk about this part so far. So what I'm doing is I'm heavily relying on this section down here, which is basically a multi-tap delay with a little bit of frequency shifting that's embedded in the delay line. So that's how you were hearing the like wow 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 kind of sounds as it was delaying. It was getting shifted. I was using the pressure sensitivity, one of my FSRs I was using here to modulate the delay time a little bit, which was creating those like, like the crazy just delay modulation sounds that you could hear all over the place. It's a thing that I enjoy quite a lot. And then I was also using kind of a switch. So with this particular one, this is a great example of how I was using one pressure sensor in a few different ways, kind of in a multi-parametric mapping, right? So I had the continuous control opening and closing the delay time. And then I had a threshold set. And every time I would go above the threshold, it would trigger a new random state on the granular processor. And that would give us like the little chirps and the clicks and all of the strange little kind of cascading sounds. Again, you'll notice there's random buttons. I have global random buttons in a lot of places. It's nice to be able to fine tune things and to control things and dial them in. It's also nice to be able to push a single button and have everything change. And so, like by doing that, you know that you're going to be affecting pretty significant change on the musical landscape, but you don't exactly know what the result's going to be. So it's so satisfying as an improviser, at least for me, to be able to work that way. So that's what was happening there. Honestly, I think that was kind of the bulk of what was going on in that section. The rest was just a lot of long delay, a lot of feedback in the delay line. I'm going to see if I can figure out how to kind of get us to a different section of the piece. There we go. I'm fast forwarding so you can hear the TCOs. These synth engines are being used now. So it might not have been visible or kind of apparent what was going on, but the whole time that like noisy sound was happening, I was holding really tightly onto the trumpet. So this is a mapping thing, I promise. Basically, what I decided to do, and what I've kind of learned by trial and error, is that I really like having to hold on to activate a sound. You know, with an acoustic instrument, if you don't give something to the instrument, you don't get anything out. With an electronic instrument, it doesn't have to be that way. You know, you could push a button and walk away, and it'll drone until the electricity dies or something. You know, doesn't need that input. But for me, I've decided to reverse that relationship. So I have to physically hold on for as long as I want those chaotic oscillators to be going. And then the moment that I let go, as you could see at the end, they stop. And so it gives me much more of like a tangible, kind of very personal feeling relationship with that side, which I think helps prevent it from feeling like a trumpet and a synth. It just becomes like this one unified thing. So for that side of things, I was using mostly the TCO. In terms of mapping, I had the ascending threshold on my pressure sensor mapped to this panic button, which basically just turns everything off. And then I had, some other things going on, the granular and the delay as well. But that was sort of the new element in the mix there.
Awesome. There's an excellent question, I think, that feels relevant to these couple of clips that you've shown. The person is asking about this sort of dual mindset where the electronics are your duo partner and you're responding to each other, versus the mindset of the electronics being an extension of the trumpet. So the question is how you sort of shift back and forth between these two ways of thinking.
That is such a great question. I don't know if it's something that I think I don't know if I choose like a role very consciously. I do go back and forth between feeling as though the electronics are a duo partner or responding, and feeling like it's truly just one unified sound. But I think working with this instrument and performing and improvising in general, it all comes down to just listening as deeply and attentively as I possibly can to every single thing. Because with this instrument, especially if you've got a sensor mapped to a global randomization, it's so easy to just become trigger happy and be like, random, go, and like, there's no, that is the easy thing to do. What's harder and also more rewarding is to be listening so closely that at any moment you might be going in to randomize something and you'll be like, actually, no, I'm just going to let this one ride. Like, I'm going to let this play out. I'm going to sit here for a minute. And those are the moments of suspension when beautiful things start to happen. So it's always about kind of, I don't think about the tech when I'm playing. That's a really big thing. Like, I'm really trying to get into just being a performer and improviser and listening as much as possible. If I'm thinking about the tech, it's usually not a very good performance. You can see it. You can hear that I'm wondering about the calibration of the, the valve, and it's all just, but listening, listening in that way allows you to like hear a truck go by down the street 3 blocks away and to somehow bring that into your piece and make it part of it. Or I know there's this one thing I remember from a concert I did back in, I think, February or January of last year, where someone came in halfway through my set and they slammed the door of the concert hall, and it got picked up in my mic and it got recycled in my delay lines and it got granularized, and people, it just became part of the piece. And I actually think it was really beautiful. But there's a state of mind that you can be in to make that beautiful, and there's a state of mind you can be in to make that like a very annoying thing. And I always try to embody the first, where any sound is something that in the moment you might abandon everything else in order to pursue. I hope that made sense.
Yeah.
So it's all about being willing to kind of let everything go at a moment's notice.
Right.
Yeah.
I love that answer. I have what might be a good kind of last question.
Okay.
This is asking, when you're starting a piece, what is the framing idea? Is it the interaction with the electronics, or is it a certain type of sound you're going for? Or is it a certain type of gesture that you're interested in? Or is it something else?
Personally, I'm usually motivated by kind of a concept, like a very conceptual thing, like the piece that I showed you at the beginning with the light bulbs. This all started because I had this idea about what would happen if you saw a gigantic whale floating through space, like lost in space, who had another space traveler who somehow got swallowed by the whale and was now living inside of this whale, and together they were slipping through the like folds in space time and like going backwards and forwards and like doing these big leaps in time and space. I know it sounds crazy, but that's where it started. And the light bulbs were these little caretakers, these creatures who also lived inside of this whale and kind of took care of things and also created a lot of mischief and like, you know, and and that's where it started. And so I had this idea. I just thought it was so fun and like whimsical and bizarre. And then I started to compose the sounds, and then the sounds required technology, and then the technology revealed new sounds, which gave me new ideas for technology. And so those two things kind of were built at the same time, step by step. But I always start with some kind of totally weird concept. Most of the time, the audience or the listeners never really get to know about the concepts because they're not that important. That part's not that important to me. It's important part of the process for me, but it's not so important that the audience knows about the whale necessarily. Yeah.
Right.
I hope that answers the question. But, yeah.
Right. So every decision is in service of a big, invisible, personal concept.
Yeah. And just to wrap up quickly, I think that that's such a valuable thing to constantly be kind of holding yourself accountable for as a composer or a performer, to be saying, is that, especially with electronic music, I mean, goodness, where you have every option, everything is possible, every sound, every instrument. I mean, it's crazy. So if you have an idea, concept, some kind of mind or image in your mind or a narrative, to constantly be saying, does this sound or tool or approach serve that purpose? Does it really do that? Or is it just cool? You know, there's a little bit of a shiny object syndrome that can really screw us up when we're trying to like make something. We're like, ooh, new sequencer. Oh, cool. New Max object I didn't know about. And before you know it, you've like lost the original path. And just, you know, I always try to tell myself, there's time for that later. We'll put that on the shelf. Thank you very much. I'll come back to that awesome thing. But I'm back here now because this original idea came to me strongly enough that I want to honor it. I want to see it through and like kind of, you know, give it time to develop. So,
yeah.
Yeah.
Amazing. Shiny object syndrome. Very dangerous.
Oh, yeah.
Nice. Excellent. Well, Sarah, thank you so much.
You know, for those of you who I wasn't able to get answers to, I guess what I can say is, you know, feel free to look me up on social, just Sarah Belle Reid. I'm pretty active on Instagram. I'd love to hear from you. You can totally say hi. I'll mention that I am also very active on a platform that's called Patreon, which is it's not exclusively an educational platform, but I use it to share a lot of patch ideas and little tutorials and things like that. So you can also look me up there and say hi and find me. It's just patreon.com/Sarah Belle Reid. Yeah, I'm always happy to chat, hear about what you're working on, offer ideas if I can.
So that was awesome. I learned so much and feel super inspired. So Sarah, it was great to spend this time with you and get to know your work more. So thank you for all of this.
Thank you so much.
Have a great day.
Bye.
Bye.